Thank you, Svetlana. Thank you also to the organisers. I mean, I would like to thank you for what's been a really excellent and very thought-provoking conference. And I mean, I've learned a lot. And of course, it's a tremendous honour to be asked to give the final talk. I mean, it is an honour, but it feels like a tremendous responsibility to try and summarise all the thoughts we've had in this week. And I'm not going to manage that, but I will offer a few thoughts. So I phrased this in constraining the Fermi paradox. So the Fermi paradox is something that interests me a great deal. Of course, it'll be familiar to all of us. And it's the apparent paradox that if you think that extraterrestrial intelligences are common in the universe, then why don't we see them? Of course, strictly speaking, it's only a paradox if you assume these alien intelligences have to be common, and then it's a paradox we don't see them. Really, it's just a question. I mean, if the question has to have an answer, and that there is possibly a simple answer that we don't see them because they don't exist. But obviously, the search for extraterrestrial intelligence in all its forms, the search for technosignatures, this is what we're trying to get an answer to. You'll recognise this patch of sky, I'm sure, many of you, with our nearest star, Alpha Centauri, and the Southern Cross and the Southern Coal Sack. But I would like to just make the point that I do think there is a paradox here. It's not just a simple question, where is everybody? Because we now know that all of these stars, to first order, all of these stars in this image will have planetary systems. We know that the laws of physics and chemistry are common. We know, I mean, common to all of these planets. We know that these laws of physics and chemistry can produce living things because here we are. And indeed, life on Earth appeared pretty quickly after the Earth itself formed. So all of this would lead us to think that life is common. And yet still, we look out into the universe and we see nothing. We see David Brin's great silence, or what Paul Davies called the eerie silence. We see a lot of interesting astrophysics, but we see no evidence of minds at work. And perhaps if the universe has or has had many technically capable entities in its past history, perhaps we really ought to see some evidence of it. So I do think it's a paradox, and I do think it's a major uncertainty in modern science. I think it's right up there with dark energy and dark matter. There's something fundamentally that we're misunderstanding, I think. Somewhere between planets and intelligence. I mean, doubtless there could be many of Robin Hansen's bottlenecks, and we'll come to that. But there is a fundamental issue here as to why the universe seems so empty. But anyway, this is what we're trying to ascertain. I would just like to add one caveat. Let me just see if I can advance the slides. And stop me if anyone else has mentioned this quote from Stanislav Lem already. But I think it's interesting. In his science fiction book Fiasco, Lem did make this observation, and it was in the context of trying to explain why we hadn't discovered any alien life until finally we did eventually. But his argument was that the culture of science is biased against it. And maybe the reason we're not finding evidence for life is because we're all young scientists are trained that it's a fool's errand and we shouldn't be trying. So I'm going to read this quote from Lem for those of you who are not familiar with it, from Fiasco. The primary rule of observation, this is the rule of observation in the world he's describing, said that whatever did not clearly show up as an artificial source had to be considered a natural phenomenon. Astrophysics had advanced to the point where it possessed sufficient hypotheses to explain, in inverted commas, every kind of observed emission without resorting to the existence of other beings as the senders. A paradox arose. The greater the number of theories astrophysics had at its disposal, the more difficult it became to prove the authenticity of an intentional signal. I think we have to be open to this. I mean, it's not impossible that there are things going on in this universe, and I've just made the assertion that we see no evidence of minds at work. We have to be open to the possibility they might be there, hiding in plain sight, and some of these things that we've been interpreting as natural astrophysical phenomena might in fact have intelligent sources. Still, I have to say, and Jill Tarter's comment has been mentioned several times, that we would know if we came across anything that had been really produced by an extraterrestrial intelligence. Probably we would know, and I think that's right. But that, of course, just turns us back to the paradox again. The good news is, as we've heard in this meeting, we do have many avenues in which to explore this question. And in the last few decades, obviously the field has expanded rapidly beyond just the conventional radio SETI. So we have all of these tools as well as all of these new theories that we can test. So I think we do know what we have to do to try and get an answer to Fermi's question. It doesn't cost very much for us to engage in these passive searches like radio SETI and expanding that to optical SETI and moving that to other possible means at which signals might be transmitted across the universe. And we should obviously build on that. We should expand these searches. And eventually we may indeed detect some signal, or we may not. But if we don't, then at least we may be able to put tighter upper limits on the prevalence of communicating civilizations or technological entities in the universe. We might expand beyond that, though. Of course, we're now approaching the era where our telescopes are now becoming sufficiently powerful that we can dream of looking for spectral biosignatures in the atmospheres of other planets. So this is obviously an enormous field since the discovery of the first planet around 51 Peg in 1995. And now we've found thousands of these exoplanets, and our telescopes are now just perhaps on the cusp. James Webb, not quite for Earth-sized planets, but the next generation Habitable Worlds Observatory, next generation beyond that, large space-based interferometers like the proposed ESA's LIFE concept, and as Sarah Seegard gave in her excellent review of some of these possibilities, on the more distant horizon, we might envisage putting detectors at the gravitational focus of the sun, at 550 astronomical units or more away from the sun, which would give tremendous spatial resolution, but of course also tremendous light gathering power to enable us to have high signal to noise spectra of very small parts, perhaps even just small fractions of an exoplanet. So all of these, we're at the very beginning of this process, really, with JWST only a couple of years into operation. But these are obviously astronomical tools that have great potential for identifying both biosignatures and possible technosignatures in the atmospheres of extraterrestrial planets. So obviously we should be pursuing that. Then we've got the astronomical searches for large-scale evidence of extraterrestrial engineering, so Dyson spheres, etc. And it's really great. Just as an aside, having talked about the culture of science, it is very refreshing how many papers on these topics are now appearing in mainstream astronomical journals like the Astrophysical Journal and the Astronomical Journal and monthly notices. 20 years ago, most of this work was only getting published in quite obscure places, and it wasn't really being taken seriously or even coming to the attention of the mainstream astronomical community. And now it is. So I do think that's tremendous progress. We should be searching, we can search as we explore our own solar system. It's pretty obvious that barring some catastrophe in the rest of the 21st century, we're going to be increasingly exploring our own solar system. And as we explore our own solar system, we should be keeping both eyes and minds open to the possibility of finding extraterrestrial artifacts in our own solar system. And of course, that was Joseph Lazier's talk on day 2, and I'm going to say a little bit more about that later on. And then perhaps more controversially, in the fullness of time, we may want to think that we're going to have to send out space probes of our own. Now, at the moment, this sounds outrageous, of course. The stars are so far away, the technical ability to get spacecraft to other stars on a time scale that's compatible with human society and human lives, I mean, this is a tremendous challenge, because obviously it would mean getting space vehicles to travel at some 10% or more of the speed of light, and we're not there yet. On the other hand, there are some ambiguities that are going to start to show up. We might imagine that a next generation space telescope will take some spectra of a nearby exoplanet, and it's got these molecules in its atmosphere. And are they really biosignatures or technosignatures? And there's going to be a lot of ambiguity interpreting those data, and it may get to the point where just astronomical means, just getting higher and higher signal to noise spectra may not be enough. I mean, there may come a time when it may be necessary to go and make in situ measurements of these places, and that's obviously for the quite some way down the road. But I think we have to be mindful of it, because in a universe where there might have been many other technical civilizations before us, many of these technical civilizations may have worked their way down this list, realized that there's a sun-like star sitting here we are in this sort of mid undistinguished part of the galaxy with an interesting planet number 3, and it's got an interesting atmosphere, and maybe it's inhabited, but they can't tell. So, you could see that maybe they would have decided to send the probes to visit us. And of course, currently we have no evidence that they have done, which doesn't mean they didn't, of course. There are lots of places to hide in the solar system, as we've been hearing. But I just want to come back. If I just go back to, sorry, this is my first picture here, something I did mean to stress, another reason why why I do think Fermi's question is a deep question, whether or not you accept it to be a paradox or not. And that is, of course, the galaxy is not only very large, with a very large number of potential sites at which life or intelligence could arise, it's also very old. So I said that we could be pretty sure that all of these stars have planetary systems to first order. But then, as Eric Zachrisson showed, and also Charlie Lineweaver a few years ago, the average age of rocky planets in this galaxy is about 7 billion years. So the average age of these planets that presumably are here in this image are 2.5 billion years older than the solar system. So that provides a tremendous amount of time. If life was common, it provides a tremendous amount of time for biological evolution, technological evolution, and for the appearance of activities which you might think we would have noticed if they were artificial in origin, even bearing Lem's caveat in mind. Anyway, what I want to do in the mid part of this talk is to try and say something about why I think the search for extraterrestrial artifacts is not mutually exclusive with SETI. Of course, in fact, the whole point is that none of these, as I say at the top, none of these approaches are mutually exclusive. We can work through them all in parallel, except the one at the end yet, which we don't have the technical capability to engage in. But all of these searches for life elsewhere in the universe are not mutually exclusive. So we should be doing all of them. But I do think the search for extraterrestrial artifacts, that's sometimes dubbed SETI, does have some advantages over what we might call classical SETI, or just passively searching for signals of artificial origin. And here I want to recall especially Joseph Lazio's presentation and other talks on day 2 that governed looking for artifacts in the solar system. And I think the key point, as has been made by several speakers, is that SETI requires the transmitting and the receiving entities to more or less coexist in time. And this was the point made by Amedeo Balbi in his talk. So unless these technologically capable extraterrestrial entities are very long-lived and or very common, then it's unlikely that they're going to coexist in time and space, I mean, within the galaxy. So the chances of us receiving a signal would seem to be quite low. I think also postulating numerous long-lived extraterrestrial intelligences in the galaxy is probably incompatible with other aspects of the dark, um, the Great Silence, and the other lack of the evidence of extraterrestrial activity. Now, I had in mind here Alex Ellery's talk, because Alex thinks that we're maybe on the verge of developing self-replicating tools, and these self-replicating tools could then go and build a lot of stuff for us: starships, space colonies, Dyson spheres, all at minimal cost to us because we built these self-replicating things to do it all for us. Now, if that technology was at all prevalent in the galaxy, and you really might expect that we would see some evidence of this of all this activity around us, and yet we don't. But of course, I draw your attention to Robin Corbett's poster. This is his mundanity theory for solving the Fermi paradox, in that life might be common and technologies might be common, but there could be a cap to technological progress, which would mean that technological societies or technological entities might get to our kind of level, or a bit advanced, a bit more advanced, and then stall because there are no new technologies beyond some relatively modest point. And this is a very thought-provoking idea, I have to say. Of course, it would address the non-detection of Dyson spheres and other mega structures if that technology is for some reason impossible. It still leaves the universe looking quite silent as to, our own level. Again, we had several talks, our own level on this, our own level of technology is we're beaming messages out into space. And so if there were lots of other societies, even at our own kind of level, beaming things out into space, then we still might, we might eventually expect to find it, and we haven't yet, but then maybe we just haven't looked hard enough. Even the megastructures around stars, which at first sight you would think would be long-lived, they might outlast the civilization that built them. But here I'd like to draw people's attention to Brian Lackey's talk in the Pacific time zone sessions, and also his paper from last year, where actually these megastructures, they're not going to last very long once they cease to be maintained. Because once they start to be maintained, the elements will just start drifting into each other, and you'll have a tremendous Kessler-type syndrome. And eventually, all of these megastructures will probably just get ground to dust. In which case, they might not be a long-lived technosignatures after all. Except we might hope to see the dust into which they've been ground, and I'll come to that. Come to that shortly. So. The one advantage of searching the solar system for artifacts is that we do have the potential to integrate over the whole history of the galaxy. It began galactic archaeology. But even if there are no extraterrestrial intelligences extant in the galaxy at the moment, if there have been many of them in the past, and they've been distributing material around the universe, around the galaxy, then the more of these civilizations that have been in the history of the galaxy, the more of these artifacts will be lying around, and the greater the chance that we might stumble upon them. So this has the advantage of integrating over 10 billion years, or if we're going to use our solar system as a search location, integrating over 4.5 billion years of galactic history, rather than requiring the transmitting and receiving, the transmitting civilization to coexist with us in time. So this is the main strength of artifacts, I think. Now, this isn't original. Having said that, mainstream journals often don't publish work of this kind, it is true that Nature put this paper on their front cover in 2004. And this was the Rose and Wright paper arguing that inscribed matter as an efficient means of communication with an extraterrestrial civilization. And the conclusion of their paper was, our results suggest that careful searching our own planetary backyard maybe as likely to reveal evidence of extraterrestrial civilizations as studying distant stars through telescopes. But of course, they're not mutually exclusive. We don't have to stop studying distant stars through telescopes while we also search our own backyard. And I draw your attention to this excellent white paper. I know that many of the authors of this white paper are involved in this meeting. The opportunities for technosignature science in the Planetary Science and Astronomy Decadal Survey, which made the point that as we go explore our own solar system, then it doesn't cost us very much to keep our eyes and minds open to looking for whether we find any artifacts of alien or extraterrestrial origin. I just want to draw an implication to optimistic solutions to the Drake equation, because I know that it's easy to argue, I mean, how many of these artifacts are we likely to find? And the answer might be not very many. But that does depend on how many technically capable civilizations have existed over the history of the galaxy. And here, I do think what we might call SETI optimists, those who would choose optimistic solutions to the Drake equation, may have painted themselves into a bit of a corner. Obviously, an optimistic solution of the Drake equation is all these factors equals 1, and then the number of civilizations extant at any given time is about equal to their lifetime. This is Almeida Balbi pointed this out. But what Drake has done here is he's equated the rate of the origin of technological civilizations. He's multiplied the rate of the appearance of technological civilizations by their average lifetime to get this equilibrium number. But regardless of what L is, if you're an optimist and you think all of these fractions in the equation are close to unity, then it implies that one technological civilization arises every year on average. And so regardless of what how long they might live for, it implies the galaxy, since it's 10 to the 10 years old, might have produced 10 to the 10 extraterrestrial intelligences. So if you're a SETI optimist, if you're minded to put all of these factors equal to about 1 in the Drake equation, then you're kind of expecting the signs of extraterrestrial intelligences to be really common, because you kind of conceded that 1 star in 10 might have hosted a technological civilization. That is just a consequence of putting all of these numbers into 1 in the Drake equation. Now, it's perfectly true. You don't have to have an optimistic solution to the Drake equation. Alfred Russel Wallace, in his 1904 book, Man's Place in the Universe, he didn't phrase it in terms of Drake's equation, of course, but basically his estimate for F subscript I was 10 to the power of minus 14, because he thought evolving intelligent life from simple life was so unlikely. I mean, obviously, if Wallace's estimate was right, if you put F subscript I to be 10 to the minus 14 into the Drake equation, then regardless of what the lifetime is, it sinks it. We would be alone in the galaxy if the probability was that low. So we don't know. So we have to try and find out. Here I just want to put in a plug for work I'm doing with my colleagues Lewis Pinot and Brian Lackey. We have this article which we're just about to submit, and Brian and Lewis have talked about this in the Pacific time zone sessions, but I don't think it's been mentioned. At least I haven't spotted it being mentioned in this time zone session of this meeting. So here we see Jack Schmitt on the surface of the moon. This is from Apollo 17, and here obviously is a technological artifact in the form of a lunar rover. And the question is, as we explore the solar system, might we expect to find alien artifacts on the moon? So everyone's probably thinking in terms of trying to find a big artifact, something like the obelisk in 2001: A Space Odyssey. The monolith, I'm sorry. And of course, we should be mindful to that. I mean, for all we know, large alien extraterrestrial visitations to our solar system might have occurred, and they might have left large stuff behind. So we should look. But Archipov's idea, sorry, backtrack a bit. This work is based on ideas published by Andrei Archipov. who is a Ukrainian astronomer, and he was active in the late in the 1990s. But unfortunately, he was only able to publish in fairly obscure places, and this place is the Journal of the British Interplanetary Society. But Archipov's key idea is that technological civilizations, if they arise in the galaxy, are going to start to produce a lot of space debris. A lot of this space debris will eventually get blown out away from the planetary system in which it was formed, into the interstellar medium, where it will accumulate. And the more artificial debris is, I mean, these will be micron to submicron sized artifacts, not a big monolith. But things produced by disintegrating Dyson spheres, for example, as per Brian Lackey's work, or the consequences of asteroid mining, or whatnot. But the point is, the alien technological civilization might not have to engage proactively in a deliberate policy of interstellar exploration, in deliberate program of interstellar exploration. Even if it doesn't, it won't be able to contain all the artifacts that are going to be drifting out from its host planetary system, collecting in the interstellar medium. The solar system has been around the galaxy many times over the last 4.5 billion years. So as the solar system plows through the interstellar medium, then it may be that we may be running into some of this artificial debris, and it may be collecting in places like the moon, which have no atmosphere, no erosional processes, and might be preserved on the moon, and other airless surfaces in the solar system. But the moon is currently the most accessible to us. So this is the idea of looking for micron scale extraterrestrial artifacts on the moon to see whether or not we could constrain the existence of a cumulative number over integrated over 4 billion years of debris that's been accumulating in interstellar medium due to alien technological processes. So it's not. I don't want to lead you up the garden path. There isn't going to be a lot of it. The only thing I can say is the more technical civilizations there have been in the history of the galaxy, the more debris there will be, and the greater the chance of finding it. Of course, on our horizon, we don't know whether mining the moon will get to anything like this kind of scale. Many of us may hope that it doesn't. But if it does, if we start to process a lot of lunar regolith for whatever processes, reasons we may have in the coming centuries, though there's clearly a pipeline from this digging machine that's digging up the lunar regolith. Before the regolith gets turned into concrete or mined for helium-3 or whatever it is, it's going to have to go along this conveyor belt to a place where it's processed. So you could imagine surrounding that conveyor belt with a CT scanner and other tools, searching for the needle in a haystack possibility that alien artifacts might have accumulated on the surface of the moon, because they've drifted into the solar system from the interstellar medium, even in the absence of our planetary system being deliberately targeted by alien visitors, which might have happened as well, of course. So, one of the things that interests me, I don't have time to really justify this, but sorry, I'm just scribbling my notes, but I'm trying to find my notes. Robin Corbett's poster, and Robin gave quite a good summary of all the different solutions to the proposed solutions to the Fermi paradox, and there are dozens and dozens of them. One solution, though, does remain the zoo hypothesis. If we don't see any extra evidence for extraterrestrial technology, then there are two obvious solutions. One is it's not there, so that would be we're alone in the galaxy, or it's deliberately hiding from us. So that's Andrew Ball's zoo hypothesis. And the aliens might be if they were to engage in be serious about engaging in a zoo hypothesis. Here's a rather sad Earth. I found this image on the internet. A rather sad Earth in the behind the bars of a zoo, and we've been quarantined. They might go to enormous lengths to hide their technological activities, like shielding their transmissions, making sure that all their waste heat and everything else they're doing just looks like it's disguised as an astrophysical natural astrophysical source. But they might have great difficulty in preventing all this dust or space debris that's been produced by themselves and by precursor technical civilizations from just drifting in from the interstellar medium. I mean, drifting through the bars of this zoo. It might be difficult for them to keep that out, even if they were hiding from us. So my colleague Dirk Schultz-McHugh and I have made this argument in this article that was published a couple of years ago. The other thing, so I'm aware there are 10 minutes to go. The other thing that the alien intelligences might have difficulty hiding are the presumably rich biospheres from which they themselves must at one point presumably have evolved. So the Earth has a rich biosphere. We might imagine building large telescopes that could detect and study the atmospheres of Earth-like planets within, in our bit of the galaxy, and we'd get increasingly powerful telescopes, as Sarah Seeger mentioned, and we would identify, convince ourselves there's a rich biosphere on some planet. Once that rich biosphere produces a technology, then unless the technology totally destroys the biosphere from which it arose, this planet with its rich biosphere will still remain. So we would obviously hope to pick. This is of course an argument for combining the biosignature searches with the technosignature searches. Even if we don't find the technosignatures, if life is common, and indeed if technological life is common, then biospheres should be common. We ought to be able to detect these very rich biospheres from which the technological capable species must have evolved. Just to draw even a planet like the Earth, if you think about it, as far as we know, we're the first technological species to arise on this planet. But depending on what kind of state each technological transition leaves its host planet in and the length of time it takes to recover, a planet like the Earth will have time for dozens more evolutions of intelligent species and technologies. Presumably, I mean, if it takes 100 million years to re-evolve a technically capable species, and there's 1 billion years of Earth habitability left before the sun gets too hot, there's might be 10, even just our own planet might have 10 possibilities for 10, generating 10 technological species. And this, of course, makes the Fermi paradox worse. If each inhabited planet can produce multiple numbers of technological societies, then still it's strange that we see none. I don't have time to go through all of these other bullet points. I just want to make the point that determining whether a planet with a rich biosphere actually contains or has contained a technological species or is likely to evolve one in the future, this may be quite difficult if all we've got are high resolution, even if we have high resolution, high signal to noise spectra. And this may be an argument for ultimately in having to visit some of these planets in order to break some of these uncertainties. So I'll skip the interstellar travel bit because I'm more or less out of time. Jacob Hack-Misra has made, and et al. Made this point in a recent paper. So resolving the ambiguities that we may find in biosphere and putative biosphere and putative technosignature signals in astronomical data. I mean, we may have to bite the bullet one day and actually go and visit these places to really find out what's going on. But of course, if we do that, we're distributing our own technosignatures around the galaxy, and so it just begs the question: if there were others, in these billions of years that existed prior to even the solar system forming, if there were other technical species engaged in this activity, then it strengthens the possibility that we might find evidence for artifacts as we explore our own solar system. So we should do so. Right, I've only got 2 slides left, and I was going to finish here until Catherine Denning's talk yesterday. I wasn't going to show this slide, but Catherine made the point about the importance of policy development, and I just want to reiterate this. So as astronomers and astrobiologists, we may not really feel comfortable geopolitics. We may feel that's above our pay grade and it's not our area of expertise. But actually, a lot does hinge on how we manage this planet. I mean, this is the only known inhabited planet we know of, right? Until astrobiology tells us otherwise, this is the only inhabited planet in the universe that we can be sure exists. So that puts a tremendous responsibility on our shoulders to maintain its habitability. But it also means that unless we can get our act together on this planet, then we're probably not going to give ourselves the opportunity to break out into the galaxy and find out what's going on, because we may become one of those sad species that just extincts itself before it can organize itself in a way that stops it from destroying itself. So obviously the world at the moment, we can see that we're going backwards in many ways, but the answer to this has to be stronger global international governance. We need to develop stronger global institutions for all sorts of things, not just how we're going to deal with a SETI signal or how we're going to deal with discovering life elsewhere in the solar system or finding an artifact. And Catherine spoke to all of those things. All of those things require international levels of consensus, because otherwise they will just become yet another reason for nation states to fight each other with, and we've got enough of those, so we don't need any more. But of course, if you think about it, and I draw your attention, my thoughts on this are given in this book chapter here. Carl Sagan addresses it in his final chapter of Who Speaks for Earth in Cosmos. But I really want to draw your attention to this book, Our Global Governance and the Emergence of Global Institutions in the 21st Century. And this doesn't talk about astrobiology or extraterrestrial life or space exploration at all. It's all on why we need stronger global institutions to manage all of our other existential problems, of which we have many, like climate change and biodiversity loss and chronic warfare and chronic poverty and global pandemics. All of these things ultimately can only be addressed through at the global level. They all require stronger global institutions, political institutions. And so my point here, it's my final thought really, is that if we're going to have to build these stronger political institutions anyway to manage our future in the 21st century, because otherwise we're not going to have much of a future in the 21st century. And if we're going to have to develop these stronger global political institutions anyway, then of course some of the things we've been discussing, like who speaks for Earth, who will speak to Earth, to the extraterrestrials, who will decide what to do with an alien artifact found on the moon, then the answer is, yeah, these global institutions, which we're going to have to build anyway. Now, I know that the zeitgeist at the moment is going in the other way, and so you may think I'm naive, but the point is, I think we all have a responsibility to make this argument. So this is my last slide. I'm not sure how coherent all of that was. I've tried to bring some thoughts together. But I want to leave you with this thought from William Whewell, who wrote his famous essay on of the plurality of worlds in 1853. And in that essay, he writes, "The discussions in which we are engaged belong to the very boundary regions of science, to the frontier where knowledge ends and ignorance begins." And I think the remarkable thing is that even now, 150 years later, we're still here at this boundary. Despite all of our progress in astronomy and biology, we're still at this boundary where ignorance ends, where knowledge ends and ignorance begins. We still don't have an answer to Fermi's question. Are we alone in the universe? So all I can say is I think it's important for all sorts of reasons we try and get an answer, and we should. Our only way of digging ourselves out of ignorance is to explore the universe around us. So I think obviously we should continue with the SETI searches. We should continue exploring our own solar system. We should continue building big telescopes. And ultimately, if we don't get any satisfactory answer out of that, we may start having to think about building starships of our own. Okay, thank you very much. I'll finish there.
Thank you, Ian, so much for this wonderful talk. Big applause to you. And well, there is a very lively discussion on chat, which I read through, and there is one question so far. Please don't hesitate to type questions in Q&A box. So one question from Jean-Luc Margot that the Drake equation, in short, reconciliation. The Drake equation predicts a number, which is just a number, not evolving number, let's say, a fixed number. And whether this is right or wrong, we can talk about this endlessly and what numbers should be in these equations as well. But all it takes for SETI is just to take one. We don't care how many are there. We just need to get one detected, and then we can start from there. Any thoughts on that?
Oh yeah, I agree. I mean, clearly, if we discover even one evidence for one extraterrestrial intelligence in the galaxy, in a sense, that immediately has dissolved the paradox. Well, it's partly dissolved. Maybe that's too strong. It tells us we're no longer alone. That is true. So that's provided that answer, and that would be a very important answer. Would it quite dissolve the paradox? I mean, suppose we discovered one more, and then in the next 100 years we didn't discover any others. You've still got the issue as to why these extraterrestrial entities are so rare. And we could talk about the reasons for that, and probably it would be some great filter between the origin of life and the development of a technology. But yes, obviously, finding even one would be a tremendous thing, because it would prove that we're not unique in the universe. So I agree.
All right. Maybe I just ask some questions from chat, if discussion, formulate some questions there. For example, what if we are just really the only civilization in the universe? We're the first one. There must be some first at some point, yeah. So how would we deal with that? Would we have some internal conflicts on that, or like internal dissatisfactions, or how would we? I mean, we would still pursue the SETI search. What do you think?
Oh yeah, I think we would still pursue the search, because we'd kind of like to get an answer to this question. But it must be possible that we're the first, because somebody does have to be the first. And in a sense, I think this possibly is the solution to the Fermi paradox. But because obviously we do exist, right? So if there are no others, we would by definition be the first, and that must be possible. But then that does run into the kind of seems counterintuitive, given the age of the universe, given that the average planet is 2.5 billion years older than the Earth, and the fact that the laws of physics and chemistry are the same everywhere, and these laws have produced us. I mean, so there is still a paradox there. My own personal view, and it's not one I've come to. I've come to this very reluctantly. Certainly, as a younger person, I was very much in the Drake-Sagan camp, and I would have argued that extraterrestrial intelligences were likely to be common in the universe. But I've just ceased to be able to reconcile that with the absence of evidence. So I'm afraid I probably would put myself in the camp of, for whatever reason, and it would presumably be for some of these fractions in Drake's equation being very small, as Russell Wallace sort of intimated 100 years ago, possibly because something in the biology, something in the complexity of life just makes it very unlikely. And that's a pessimistic conclusion, but I'm afraid it's the conclusion that I personally have come to. But that does not mean I think we shouldn't look, because people's personal conclusions mean nothing. We're at this boundary between knowledge and ignorance, that Whewell pointed out. And so we can speculate as much as we want while we're on this boundary between knowledge and ignorance. What we have to do is get some more facts. And that does mean exploring the universe to try and get some more data points.
Totally agreed. And also, just thinking that we are alone in the universe is still an assumption, and all assumptions should be verified. So that's scientifically. Yes. All right. So another question from George Profiliotis. Given the current financial situation and all kind of funding cuts, do you see any ways to attract some other financial sources to support astrobiology and SETI research? In addition or in contrast to traditional paths of big philanthropy and grants from public agencies?
Yeah, so I mean, I'd love to have a magic bullet that I could just give you, but I have no particular insights on that. I mean, one can kind of predict that if evidence for extraterrestrial life was to be discovered serendipitously, let's hope that it happens, then this would drive tremendous public interest and hopefully political interest, and then funding would follow from that. But that may not happen because we don't we don't know. We may be alone in the universe, in which case we can't hope. We might hope, but we couldn't expect to find any life elsewhere that would drive political and public interest. So I'm afraid I don't have any magic answer to this. I do. My sense is that the public at large really are interested in this, but whether they're interested enough to get that to the attention of the politicians and policymakers who control the funding. I mean, haven't seen that much evidence to date, and so I'm sorry, I can't really be very helpful. I don't see a magic way of increasing the funding for astrobiology.
I think it would be great, like you say, if somebody has that magic bullet yes, or offers, and it's hard to see what is outside private and public. So what else is there? Extraterrestrials, they can fund us, I guess. Yes. Okay. So another question, which didn't appear as a question, but I can formulate it like this. I'm curious myself. This very puzzling number, lifetime of civilizations. So it's a value it's a kind of number you can take from 2 millions to 100 millions, and you get different number of civilizations, clearly. But where does it start from your point of view? Like on a human basis, where should we say that civilization starts? Because we saw many historical civilizations which come into existence and then disappear again. And how do we define on a human side scale beginning of civilization?
Well, in terms of Drake's initial formulation, it would start when the civilizations become communicative, because that's the F subscript C in the equation. So it would start when radio transmissions started. So by this definition, we're only a bit more than 100 years old, and of course. Then there's a big debate we can have. Those early radio transmissions were so weak they won't have gone anywhere. So, but I think formally, because of the way Frank Drake cast his equation, this lifetime would be the length of time for which they're communicative, which in his sense was be able to communicate over interstellar distances, presumably, well, in his case, by radio waves. I just want to come back though. I think, and it comes back to Amedio's point as well yesterday. In a sense, I'm not really hung up on what the lifetime is. What I think is by far the most interesting constraint imposed by the Drake equation is that all of these other terms before you get to L multiplied together, because you start with the rate of star formation and in stars per year, and then you multiply it by all of these other factors. So you end up with the rate at which civilizations form per year. Now, it's true that the longer they live, the more you have at least existing at any one time. But that's not really the point I was trying to make. The point I was trying to make is if you form one civilization per year on average, and the galaxy is 10 to the 10 years old, then you're predicting that you would have formed 10 to the 10 civilizations. And that would mean that one star in 10 would have hosted one. Now that seems to me implausible, right? I'm not saying that it's plausible. I think if the rate of formation of civilizations was anything like that, then we would have noticed. But the point is, if you do like to argue that all of these factors are quite large, close to one, then you have, as I said earlier, painted yourself into a corner where you forced yourself to concede that technological civilizations have been common in the history of the galaxy. And then you do have a problem with the Fermi paradox, because if they were so common, then arguably we should have seen evidence for them.
Right. It indeed goes towards the not just defining civilization, but what flavor of civilization, communicating, technological, agricultural, and so on. Yes, I think it's a flavor what we can detect. And detecting what we are doing is detecting, communicating, and highly technological.
Yes, although just to draw your attention to, I mean, the whole of this argument is predicated on technological intelligences. So that's why I've done, the subscript ETI.
Yes.
Oh, sorry, if that's confusing. The subscript ETI would be extraterrestrial intelligence. So that's wrong. Really, I should have a qualification on that, extraterrestrial technological intelligence.
Technological, yes,
because
intelligence.
those are obviously the only ones we might hope to find through Technosignature searches.
Right. Okay. So not sure where these comments go. Jean-Luc Margot says after your previous comments that it's only true for steady state processes. It's not a steady state process. Is it for evolution of the technology, I guess. Yeah.
Yes, no. So just to interrupt, so that's true as well. And that's the other kind of implicit assumption in the Drake equation, that it kind of assumes that technological civilizations are common, even by formulating the equation in this way, because the person who raised that point is absolutely correct. It sets the equilibrium number at any given time in a steady state. So if extraterrestrial civilizations were really very rare, and I'm afraid I personally think they are, then yes, the Drake formalism doesn't work properly, because you can't reach a steady state. So that's correct.
That's right. Yeah, it was previous comment also that way. All right. So somebody mentioned that, okay, we would be lucky to have one serendipitous detection, and then all the venture capitalists would pour millions to a handful of new science actors. So that's something indeed happens in some fields. If a new discovery made, then the money go there. So that would be nice. All right. Any other questions?
Well, having said it would be nice there, sorry to push back a little bit. I mean, it might be nice in that it might make more funding available, but it would contradict. My instincts are that dealing with anything as profound as extraterrestrial intelligence does come back to the who speaks for Earth question, right? That Sagan asked in his final chapter in Cosmos. So it wouldn't be nice if people speaking for Earth was just one massively rich entrepreneur who managed to capture the alien technology. I think this is why Catherine Denning's call for paying some attention to the regulatory environment is important, just to try and stop that happening. To try and make sure that these discoveries percolate, and benefits that might accrue to them percolate through to the rest of all of our other fellow citizens on this planet. So I can see pros and cons there in trying to get the funding captured by a very rich bunch of, what we might call.
That's right. Yes, thank you for comment. Also, I think this current approach, what we have to use astrophysical missions and facilities for general science to just explore the data. And as we saw with exoplanetary discoveries, there are post-discoveries. And that is what we have to really, there's plenty of data coming for different reasons, for security, for astrophysics, for searches, for planetary defense, everything. And if we apply our techniques, which we think should find alien signals, then to this data, we can do post-discoveries. And that is also something not fully implemented yet, as I believe.
So I broadly agree, but I wasn't sure whether that was a question to me.
There's no question. It's my statement.
Okay, all right.
It's my comment, because I don't know, people don't ask questions. So it's my comment that maybe we should conclude this session with some general statements. Ian, maybe you can say a few more words and we finish this session, and then we move on to concluding remarks by Jacob.
Oh, well, thank you. But I think I've had I've had 45 minutes of my words, and
Okay.
I probably said that all that anyone really wants to hear. But thank you again for the opportunity to give this talk, and thank you again for this really excellent conference.
Okay, thank you so much for all the presentation and discussion, and now we move on to concluding remarks by Jacob, please.
Okay, well, thank you so much, Ian. Thank you, Svetlana, for chairing the session, and thank you, everybody, for all your participation and attendance. This has been really great. So this doesn't have to take too long, but I wanted first, most importantly, we have to announce the winner of our student poster contest. And then I just have some concluding remarks to share with you before we conclude the symposium. So first of all, we had 153 attendees from 34 countries around the world. This is fantastic. I'm so glad I got to meet so many new people from different places that I haven't been. And so this is just a great testament to what you can do with the online format. And so we don't have to stop it here. We can all stay connected online. So, the moment you've been waiting for, student poster contest winners. First of all, I will thank our judges, Anna Maria, Berea, Sanjoy Sam, and Richard Bennett. So thank you all, and thank you to all our students for contributing your posters. I know for some of you, this might have been the first time that you gave a talk or presented a poster video about your research. And so it was all very fun for me to watch. And so third place, we have Louisa Mason, simulating the stellar bycatch, constraining the prevalence of extraterrestrial transmitters within SETI radio SETI surveys. Working with Michael Garrett and Andrew Simeon. In second place, we have Calden White, the White Dwarf Technosignature Opportunity, working with Colin Harrison. And the grand finale winner is Benji Fields, a 2821 star optical SETI survey using HARP's archival data, working with Jason Goodman. And so please check out all these posters, check out all the posters, and congratulations all three, Benji, our first place winner, will receive a Sci-Worthy course as well. Oh, there it is. Yeah. And let's give a big round of applause to our student volunteers, Kelly Dobbit, Subsankar Palit, CJ Bale. They were behind the scenes for all the Zoom meetings, making sure everything went smoothly, designing the email templates, running the meme contest, just helping keep everything organized. So we could not have done it without our organizing committee. So thank you for everything. Just some logistics for you all. The talks and posters are being posted to YouTube. We're up to day 3 now. We'll have day 4 up pretty soon. Obviously, when this session ends, then we'll start processing day 5. And these are still private right now, but almost all of them will be made publicly available unless the presenter requested it not to. So, for now, this is content for us, but soon after the conclusion, this will be content that will be shared with others. You can share it with your students or anyone else. The Slack workspace will remain available to you indefinitely. It is a Slack Pro workspace, so you will actually have full history of all the conversations we had. You can come back in a year and search for that one conversation you had with somebody from another part of the world. And so you can keep this even just if you want to message a few friends that you make. Your Slack won't go away and you won't lose the history. And then keep an eye on your email. We'll send a follow-up survey. And if you contribute an abstract, then we'll have some information on how to contribute your proceedings paper. And so finally, just to conclude, I've been posting these historical throwbacks to the first IAU conference that talked about technosignatures or SETI. And so I thought, I really actually can't improve very much upon the concluding remarks that were offered by Harlan Smith, who's director of the McDonald Observatory. So I'm just going to leave you with some of his thoughts. The entire SETI question reminds me of the legendary argument between a philosopher and a theologian. Losing his temper, the theologian protested that a philosopher is like a blind man in a dark room looking for a black cat. To which the philosopher retorted that a theologian is like a blind man in a dark room looking for a black cat that isn't there. And so, of course, in SETI, there's something in common with that dispute. We are in a very tiny corner of an almost inconceivably vast room. We would like to find some company. However, we're not completely blind. We can and do peer around at least the very nearby parts of the cosmic room, to be sure, through some extremely narrow band filters. Also, the room itself is not entirely dark. In fact, at some wavelengths, it's annoyingly bright. But what about the cats? That's really our subject here. And so, just like we heard from Ian, this closing talk also focused on the Fermi paradox. And so, one possibility that, Michael Hart might have pointed out is there should be no other cat anywhere in the room, just not our galaxy, but the entire universe. Oh yeah, one possibility. Maybe against whatever odds scads of kinds of cats are born in the universe. Nevertheless, for many reasons, essentially none of them get old enough or clever enough to meow loudly enough for us to hear. In other words, they would truly be black cats in the fundamental sense of not radiating. Again, another solution we've heard about, to another way, why haven't the cats multiplied and spread like mice? We should be positively tripping over them, even the small dim corner we inhabit. Phil Morrison called this the Malthusian motif, but in this context, maybe it's the Maltesian trap. And, another thing to keep in mind is not only the mode of listening for cat calls, but also the need to look for what might be thought of as cosmic kitty litter. Dyson spheres and other waste heat. So we did add to this list, I think. So just to continue the metaphor very briefly, maybe some atmospheres reek of cat pheromones, as we heard about from some of our presenters. Perhaps the cats or their paw prints are here. And we just need to build better technology and leverage machine learning to find them in large data sets. Which both of these are ideas that are newer, weren't represented as much in that older meeting. And, maybe we need to broaden our conceptualization of cats to give us new ideas to look for them. And so I think this has all been great. And in the words of Harlan, it's been a real cat's meow of a meeting. I totally agree. I thank you all for your participation. If you've enjoyed this, please sign up for the Blue Marble Space newsletter. We send out information about everything that we do, and we look forward to staying connected by email and Slack. We look forward to the proceedings, and thank you so much. It's been a real pleasure to be part of this meeting, and this would not have been possible without all your participation. So thank you, and we release you. You can get back into the real world now.